I'm gonna try to get you to see it using my iPad. What is this all about? Let me see if I created it yesterday, but I hope it works. There it is. So let's say, for example, somebody says, hey, I want you to tile this floor. I'm going to give you regular triangle tiles, triangular tiles. What does regular mean when it comes to a triangle? Triangle, it means equilateral triangle, right? Because all sides are the same, all angles are the same. And you're like, well, I don't know if that's going to work. Well, let's try it. This is going to be a little, I don't have my mouse, so I have to do it this way. So what I do is, this is how you would test for it. You make a point somewhere on the ground, and you try to fill in the gap. What is the full circle is 360 degrees, correct? So we're going to try to fill that in. Do you think it's going to work? I don't know. You tell me, Mr. Erickson. I'm just watching, right? I'm just watching. So, so there it is. So I know there's a bit of a gap because it's not 100% accurate, right? This software. And so you've completely filled this in. If you think about it, every single angle here at this point that I'm interested in is 60, right? How many 60s did I have there? Right? I have 1, 2, 3, 4, 5, 6. 6 times 60, right? 6 times 60 degrees is 360. So that is the key. You want to make sure that the shapes that you're using, if you're focusing in on this point right here, that you can actually completely fill that in and fill the 360 degree gap. In this case, we would say you can tessellate. You can use it for tiling. And so how come you're done just by doing that? It's like, yep, because what you could do now, let's see if this works. I usually used it on my computer, so anyways, it does work. If you now continued this, let me copy this. You can do it. Oh, there. There. Copy, paste, right? So if we continued this, we would be able to just keep going, like, right? I keep this together and I keep putting them all together. No matter where you go, you would be able to continue this pattern and just tile that entire floor using triangles. So that works out. We only check for one corner, and it turns out that it's true for indefinite repetitions. What about pentagons? What is the interior angle of a pentagon? You do it, or you tell me. Do you remember what it is for a pentagon? We just did it. 108, right? Does that number look like we will be able to fill in 360 if we use pentagons only? It doesn't look like it, does it? So you can kind of already determine that. But if I were to take these and, oh, I'm going to make a point here on the floor, and I'm going to put these shapes against right there. I'm going to put that interior angle against the point, and then I'm going to do the same thing here. There you go. And I'm going to take this last one and fill that in. And I'm left with a gap, right? So it didn't work. It did not work. I have 108. I have 108. Sorry. And this is 108. So there's a little bit left. So 3 times 108, this is as many shapes as I could fit in there. 3 times 108. My mental math skills are down the drain. I don't want to get it wrong, right? So 324, which is not, right? This is not equal to 360 degrees. So do not tessellate. Do not tessellate. Okay. So before I just give you notes on it, I wanted you to see that this is really what we're trying to do here. So I'm not going to ask you to draw the shapes. Don't worry about it. I'm just going to ask you to mathematically show me whether or not you could tessellate. But what if I twist it a little bit? So we were all using the same shape. What if I use combinations, various combinations of various shapes? So this is, oops. How do you undo here? I'm just going to use my eraser here. So what if I use an octagon, a square, and a bunch of other octagons? Do you think that's going to work? You've seen this. You've actually been at places where you saw this pattern, right, on the floor? And you're like, wait a minute, where's that point, Ms. Dirksen? Well, okay, let's do that. We're going to focus in on just this one point. Can you fill in this gap all around? Yeah, you can. Do you remember the interior angle of an octagon? It's 135. 135, 135. And what is it for a square? It's 90, right? So 2 times 135 is 270, right? 1 times 90, which is the square, is 90. If you add these up, what do you get? 360. So in this case, you would be able to tessellate. So all we do is we just focus on the interior angle and try to see if we put them together, if we would somehow create a 360-degree completely filled in. Okay? That's what we're after when it's tessellating. So you can obviously tell that no matter which corner I go to, this happens, and so you can repeat this pattern indefinitely. Yeah. Go ahead. Sorry, I didn't see that. I was too excited with tessellations here. So let's go back to the notes here on page 20, and I will just give you, this is it for tessellations, guys. There's not much to it, really. Okay? So do the following tessellate. And remember, you have to use at least one of each shape mentioned. So if it's regular triangles, watch how I do this. You go like this, right? Interior angle of a 3-sided is 3 minus 2 times 180 divided by 3, which is 60. Okay, you get that 60-degree angle there. And watch what you do now. Check. Okay, check. You go 360 degrees and you divide it by that angle you just found. Sorry, that's supposed to be 60. And if you get a whole number, right, because 60 goes into 360 6 times, so there are 6 triangles needed, right? Answer is a whole number, therefore tessellates. Okay, so that's how you answer a question. If I ask you, hey, can you use regular triangles? You figure out the interior angle, you go 360 divided by that angle, and in fact, if you get a whole number, that means that you can go ahead and say it tessellates. Okay. Next, regular pentagons. I already told you that that's not going to work, but this is how mathematically you would do that. That would be 3 times 180 divided by 2, which is 108. Then you check, right? 360 divided by 108, and when you do that, you get 3 point something. No surprises there because I already showed you that. 3.33 repeated. Okay, does not tessellate. You can also say you cannot use that to tile the floor if it's a tiling question. Okay, not a whole number, so it does not tessellate. You do not have an exact 360-degree combination possible with the interior angle. Okay. What about this one? Yeah. Which part? Because it's a pentagon, these questions only work with regular shapes, so everything is the same. So my first step is to find the interior angle, like just one of these. This is 108 here, right? And we also know that this is 108. We also know that this is 108. There's a little bit of a gap. There's a gap left over, right? So what we're doing here is we're saying how many of these interior angles, right, fit into 360 degrees. Because remember, if you have a full 360 around a certain point, then it tessellates. That's what, sorry, that is a mistake, my bad. That's good, no? Okay. That is my bad. It's still 108 though, right? Okay. So 360 divided by 108, that's 3.33. Repeat it, does not tessellate. Anything that's a decimal, you conclude you cannot use it to tile the floor. Okay. Next, what if it gets a little bit, what if I mix up the shapes, which is most likely going to be the case. Okay, this is going to be more like it. Okay. Could you use regular triangles, right? Squares or hexagons, right, to tile a floor? Will you be able to, will these shapes tessellate? Okay. And you can tell that it will, right? It kind of gives it away. I used to not have that on there, but I think it's nice to see, right? So this is how I want you to do it. And I allow you to do this. The interior angle of a triangle is what? 60 degrees. You don't have to do the math on these ones. Like, it's okay. I get it. You know it, right? Interior angle of a square is 90. The interior angle of a hexagon, that one you might not remember. I got it right this time. So that's 120 degrees. So here you have to use a different approach, right? So what I'm doing is I'm figuring out all the interior angles that are involved here. And then you have to tell me how many of them will be required to make this happen, to make this work. So this is what you do. You go 360, and you must use one of each shape to begin, okay? So I'm going to go minus 60, which is the triangle, minus 90, which is the square, minus 120, which is your hexagon. Okay, so just go ahead and do that first. And you get, obviously, that there's 90 left over. If you do the math, right, I'll just show you that. Minus 90 and 60 is 150. Minus 120 is 90, right? There's 90 left over. So that means, right, that you have to use which other shape to fill that in. So you just look, and obviously it's a square, right? So you take a 90 away, which is a square, and you're left with 0. That is really what's happening here, right? You're filling in that gap, and so you find that it's 120 here, that it's 60 here, and then there's a 90 and a 90, right? So all together, you do fill in that 360-degree gap. And that guarantees you that you can keep using this pattern indefinitely. Tessellating is a repeated pattern. Okay, so you can tessellate or you can tile the floor using one triangle, two squares, and a hexagon. That is kind of like the combo that you need to use every time to make this work. Okay. That's tessellations right there, folks. That's all you need to do. And sometimes I will just ask you, hey, so-and-so has triangles and squares. What other shape could be used to tile. Like, what is that third shape? You come up with it. And that there's basically where you figure out the number of sides needed to fill in that. So it's almost like a backwards question there when that happens. Okay. Could you tile the floor using these ones? I don't like to give it away, but I actually don't mind at the same time, right? So we know that it's not going to work. Yeah, go ahead. But let's show this, okay? We're going to go interior angle of a triangle is 60, okay, because we're using triangles, squares, and octagons, right? So we just did octagon, so technically you should remember it. That's 135. That's 135. So you go 360 minus 60, right? You're using a triangle, you grab a square, you grab an octagon. I'm just going to go octagon there, and then you just try it, right? So see what's left. So there's 75 degrees left. So then you're like, well, what else could I use? I could use another triangle, right? And then I'm left with 15 degrees. So it can't left over, right? Right? No shape can be used to fill in gap. Okay? Therefore, does not tessellate. So if there is leftovers, does not tessellate, right? If there's nothing left, if you can get it down to 0, you're good to go, right? You could have used the same strategy here, subtracting with the first two questions. Just keep subtracting from 360 until you get to 0, and then you're successfully answering that question. Okay, let me just here. Where did I put that paper? 2021. Okay, here it is. So yeah, what can you do now? Okay, so I would encourage you to try page 21 on the back side here. Okay, so I would say homework. This page here, page 21, all of it. So this is a tiling question and then proving whether or not lines are parallel. Again, if you, in the workbook, if you go page 24 to 34, or you go page, what was the other page that I posted the key for? There was a test, there's like an old test on the back of the booklet, which you can work through. 36 to 39, right? Or 38 or something like that. 36 to 39 is what I wrote down. So, right? This is test review stuff. Okay. The keys are posted. So just go under yesterday's, I actually have them by page number. And this page here, 21, I will post later today. Okay. So what are we doing tomorrow? Those that you just joined us, I moved the test again to Thursday. Okay, so mark that in your, put that on your study sheet or whatever, Thursday. That's day 4. Okay, so that'll be first thing in the morning. So you got to come in early if you want extra time. What else do I want to say? I think the rest is